Hello, everyone. So we are Team Lumos, and this is our capstone project, Vision 360, a retrofit autonomy kit designed to bring affordable autonomous capabilities to existing commercial vehicles like taxi cabs or trucks. Over the next 25 to 30 minutes, we will walk you through a problem analysis, technical development, prototype, market research, business model, and overall solution. I want to draw your attention to the problem statement.
Mansoor is a taxi driver at a local company in South Korea. Today we will show you possible potential incidents that might happen due to human error in real life.
So let's go. I'm so sleepy. That's number one condition we can face.
As you saw in the previous video, many accidents on the road happen because of simple human error. Drivers get distracted, tired, sleepy, or sometimes they just don't follow the rules. In the taxi fleets or long-haul tracking, these risks grow even higher over long working hours. Now, full autonomous vehicles can solve many of these issues, but buying a brand new autonomous car is extremely expensive. And if you already own a fleet or own a vehicle, replacing every vehicle is not realistic. So you would need to sell your current car and invest again from zero. So instead of replacing your vehicles, we offer a much more practical solution. Vision Drives 360, an affordable retrofit autonomy kit. We install hardware and software directly onto your existing vehicle and instantly turn it into a semi-autonomous unit. No full replacement, no massive cost. Our goal is simple: transform conventional vehicles into semi-autonomous or fully autonomous units through an affordable retrofit kit. Our key objectives are enhancing fleet safety and efficiency, delivering 360-degree sensing with AI perception, providing real-time driver assistance, and enabling scalable automation without replacing your vehicles. So Vision Drive 360 is built specifically for the Korean road environments. It's modular, flexible, affordable, making it easy to scale across taxis, logistic trucks, and service fleets. Let's look at the real problems fleet operators experience today. So driver fatigue, inefficient routing, high automation costs, and limited visibility around the vehicle. These problems directly affect safety and cost. Our solution is uh, Vision 360 retrofit autonomy kit, which transforms existing vehicles into smart and semi-autonomous systems. So it provides 360 degrees sensing using cameras, ultrasonic sensors, and optional LiDAR, lightweight YOLO-based object and lane detection, real-time safety warnings, and road optimization and fleet analytics, and over-the-air updates with a cloud dashboard. So the system has two parts, essentially, hardware and software. On the hardware side, the kit includes like a front camera and number of cameras on the rear side, and also from the both right and left side. So an optional LiDAR module and then a Raspberry Pi or a Jetson Nano acting as an edge inference engine. On the software side, we provide YOLO 8 perception model and lane detection combined with sensor fusion and A-star path planning, a differential drive controller based on the uh, TurtleBot. We used for the prototype, we used TurtleBot as our vehicle. So a complete web dashboard for fleet level insights. To validate our design, we developed 2D and 3D prototype visuals. As you can see, 2D design shows our front and rear camera placements covering 204 degrees for now, and blind spot elimination using LiDAR plus ultrasonic sensors if available, and also real-time telemetry layout. And the 3D visual shows the physical prototype using TurtleBot mounts. We simulated sensor angles, field of view, cable routing, hardware stability, and we tested the entire design in Gazebo before building the real prototype. So the following is the working flow of our prototype. So first of all, through cameras and possibly a LiDAR, we'll get the images and sensor data. And through Raspberry Pi, we'll pass it to the our remote laptop. So why we're doing it right now? Because right now we have like a Raspberry Pi with 2 GB of RAM, and because of that, our inference models might not work. There are some kind of hard process in that. So in the perception layer on the laptop, we will have a YOLA model for person detection. We actually have like 20 classes for detection models. Our talk will continue about that. And also we have lane detection and traffic light detection. Also, we are thinking to include LiDAR SLAM. After these detection models, after we get all the data, it will go through the priority decision making module step. So we have like a couple of priorities. It's right now hard coded. So first of all, we have like pedestrian emergency. If there is like a person within the distance of 1 meter, it will like present a danger, and if it's even closer, the car automatically stops. It's called emergency stop. And as you can see, we have other priorities as well: pedestrian avoidance, traffic light control, lane following, and approach model. And after all, we decide what we will do next. Then these decisions moves to the motion control layer. And in the motion control layer, all the PID control, velocity controlling, and also turning left or right or something, things will happen. And through SSH, we will transfer those decisions to our total mod.
So on the software part of our technology, we have used different algorithms and models for detection purposes. First of all, we have used YOLO V8 model, which is a computer vision model to detect different objects, but we have tried to change the architecture for lower computational costs, in which we have resulted in achieving to reduce the number of parameters from about 3 million to 1 million, basically 3 times lower number of parameters. And for the floating point operations, we have achieved to reduce it from 8.9 to 3.9 millions, which is about 2 times less number of operations. And we have 20 different classes in training this model, which are basically people, different types of vehicles, traffic lights, and traffic signs. And for the lane detection, we have used half transforms, which is algorithms basically used to detect lanes. Uh, these algorithms look for strong edges using canny function and combines the lined up edges into clear lane lines. And which lanes will help our autonomous vehicle recognize left and right boundaries of the road, in which that car can stay centered and follow the road safely.
Hi, I'm Cho, and today I would like to talk about the demonstration aspect of our project. So throughout the entire semester, our engineering team developed this pipeline in parallel, the software and the hardware pipeline. So the most time-consuming part was the startup setup because we have to test on the multiple OS so that we can figure out the most suitable OS for both the our system and our camera. So the reason why we set it up on Ubuntu 2.22.04 is that firstly is pretty lightweight since we are applying using the Java version on the Thunderbolt, and it's worked with the it was pretty well with our system, which is the core component of our whole operation. And we also implemented similar structures pattern similar OS on the virtual machine. The only difference is that on the virtual machine, it is a desktop version. The reason why we don't use the Raspbian OS is that it is not working well with the iOS, so there is no way to use it, even though it worked pretty well with the camera we have purchased. And then we kind of like use establish a SSH connection to connect the data port and the virtual machine. And we also implement the optimization later to make the processing rate a lot faster. For the software pipeline, we have pedestrian detection, traffic light detection, lane detection, and road sign detection. For the pedestrian and road sign, we are going to use the learning model. But for the traffic light and lane detection, we are only implementing the computer vision techniques because to use for models, it would be too heavy for our device, and most models in the market, there is no separate model for traffic light, and we can actually improve the YOLO model for the traffic light, but it would be less cheaper and battery memory consuming to just use the computer vision technique. So we apply the color mask and edge detector to remove the noise as well as to detect lane edges uh, and the circular shape of the traffic lights using a computer vision technique. Here the formula is the formula that is used for uh, what is that? Traffic light detection. So as you might see that our program is currently detecting traffic light and road sign as the same. That is why we are currently training a model by ourselves to detect the Korea road sign correctly. So let's take a look at the videos. This is a 30 frame per rate video taken from the car of one of our teammates. Is around 2 minutes. However, the processing speed is kind of slow on our virtual machine as well as the data. So it takes around 5 minutes to process all the frames. So as you can see here, even though the original frame is 30 frames per second, the actual processing rate can go up to yes, it's just stay around the 4 frames. Well, the correction detection is pretty correct. It's detecting the traffic, and it's also detecting the state of the car. And because it's detecting a linear velocity, angular velocity, and it's just, and there is also so as you can see here, we kind of like separate the detection zone in the lower part into 3 zones: left, right, and middle part. And this zone played a crucial role in deciding whether the car should stop or not, based on the person approaching. It's like, so this is the board we are using. So we have a Raspberry Pi port and the OpenCR, and this is a camera we finally decided to set it on because the Raspbian camera is not being detected by our Ubuntu OS system, which is super unfortunate. Because I was very excited to use the camera.
Hello, my name is Asbek, and I'll carry on the presentation from here. So I'd like to go with market research. So our main target here is South Korea. We'd like to start with the South Korea. To be more specific, we're targeting three cities of South Korea: Incheon, Seoul, and Busan. So major cities, and also these are the three our target markets that we want to sell our product to, and then who we think will benefit the most from our product. First one is logistics fleets. So we are targeting companies, like logistics fleets companies, that medium to big size companies, small to medium sized companies, to be more specific. So they might benefit from our product, and that's who we are targeting. Second one is taxi service companies. So the example can be Uber, and then the companies like Kakao Taxi. So this can be very huge, but still, the again here, medium to small to medium sized companies, we think will benefit more from our product, and whom we will target. Third one is, this is for future. This is what can be a future. So we are thinking about the public transport fleets, so the governments whom we can collaborate, and then this might be a future potential market. So they might benefit from our product, and the question might come, why they might be interested. Why they might be interested. So because there might be issues. These three target markets have common the problems, which are high accident rates, dense urban traffic, and budget constraints, high readiness to adopt low cost tech. So that is why we think our product might be key to solving their problems. So to go with more with the market research, we have a total addressable market. So starting with Korea, as I mentioned earlier, we are first starting with Korea. So the potential market here is 1.2 trillion Korean won, and we also want to expand globally, where the numbers are going to increase even more, as you can see from the figure here. So to talk more about the person, so we have a persona. His name is Mr. Kim. He is an operations manager who works in the fleet uh, company, like the first one, logistics fleets company, and he's operations manager, 54 years old, and from Seoul, South Korea. So his priorities are safety, delivery efficiency, fewer breakdowns, and key selling point. What we are going to, what our product will be valuable here is our product gives real-time alerts and optimizes routes. It keeps operations smooth. So it also, to be more specific, it also keeps the cars safer, so that it turns them into semi-autonomous, where it helps a lot for the driver. Even when the driver is feeling a little, sleepy, the our product can help here, can come in handy, and then help the driver. So from now on, my teammate is going to continue the presentation. Thank you very much for your attention.
Competitive landscape. There are many companies working on autonomous driving today. Mobileye makes ADAS systems for car manufacturers. Wavy and Ghost focus on AI-based autonomous driving. Coma.ai sells low-cost retrofit systems. But Vision Drive 360 is different. Our system is low cost and can be added to any existing vehicle. It is trained with Korean road data and it works well in local conditions. We also have open architecture, which means companies can connect our system to their own fleet platforms. And we offer full 360-degree awareness and fleet management tools for large companies. Moving on to the business model. Our business model is simple. Customers pay one time for the hardware installation, then pay a monthly subscription for AI features and updates. For the first year, everything is under warranty, including repairs and calibration. After the first year, customers pay a monthly maintenance fee for repairs, checkups, and support. This model helps companies upgrade their current vehicles without buying new ones. Pricing framework. Our pricing is easy to understand. The hardware installation starts from 3.6 million won per vehicle. After 1 year, the maintenance fee is 45,000 won per month. This covers repairs, calibration, software updates, and customer support. The software subscription price depends on how many vehicles the customer has. Overall, Vision Drive 360 gives advanced technology at an affordable cost.
Hi, this is Georgia. I will talk about operations part of our presentation, which is an important part of any business running. Let's start with supply chain and assembly. Vision Drive 360 is built using automotive-grade components, and they are sourced from suppliers in South Korea. All the hardware is integrated, also calibrated and tested in-house using thermal, vibration, and road scenario checks. This ensures every kit meets high reliability standards and is optimized for South Korean roads. Moving to logistics, delivery, and installation, a centralized warehouse enables us 5-day nationwide delivery, and with authorized installation centers in major cities of South Korea, we can complete sensors mounting, wiring, and calibration within 2 to 3 hours. Each vehicle goes through a short road test and then receives OTA updates for firmware and AI modules in diagnostics. Moving to distribution channels. Our product is distributed through a hybrid model, direct B2B sales to logistics fleets, taxi operators, and mobility services. And talking about the fleet platform, we will have it integrated to offer our customers a safety add-on in region with scalable deployment. And of course, with health, everything is not at the end, because we'll have after-sales support and maintenance for our customers. All systems include 1 year full warranty that covers repairs and updates. Afterward, a monthly maintenance plan provides a sensor recalibration, repairs, customer support, and continuous software AI upgrades. And lastly, our in-house R&D team works continuously to improve the AI models and also hardware and software parts to improve the performance and edge case detection. And by feeding field data and customer insights into our models, we're going to continuously and regularly upgrade our models and provide OTA improvement to our customers. So every vehicle we deploy gets smarter and safer over time without even adding new hardware or software. That's all for operations part. Thank you.
So for our marketing strategy, we decided to break everything into three simple stages: awareness, pilot program, and expansion. Each stage helps us slowly build trust and show real results instead of trying to jump straight into mass adoption. First, awareness. Here, our goal is basically let people know we exist and how then we are legit. We will participate in industry demos and tech events where fleet managers and mobility companies gather. Instead of just talking about our system, we want to show in action how the ADAS retrofitting works and how the sensors react, how the dashboards look. We will also do public showcases, things like live demonstrations that visually show braking assistance or alert systems. This makes the technology feel more real and trustworthy. And of course, we'll run online campaigns, especially on platforms like LinkedIn and YouTube, targeting logistics operators, taxi companies, and anyone in fleet management. The whole point of this stage is to build visibility and spark interest. The second stage is a pilot programs. This is where we actually work with fleet partners instead of asking them to commit to hundreds of vehicles immediately. We start small, 5 to 10 vehicles per partner. This gives us a chance to gather real-life data, accident reduction, fuel savings, and overall operational efficiency. These KPIs are extremely important because they prove our system works. Once we have a solid numbers, it becomes much easier to convince those same partners and new ones to scale up. And finally, the expansion stage. Once the pilots show good results, we begin to grow nationwide to make adoption easier. We'll set up installation sensors across the country, not just like in Seoul. Seoul. We'll also create partnerships with fleet management companies so our system can integrate into platforms that operators already use. This makes Vision Drive 360 feel like like another tool to manage and more like a helpful system that naturally fits into their workflow. So overall, the strategy is simple. First, get noticed, then prove the value, then finally scale with strong partners and nationwide accessibility.
Intellectual property part. Okay, intellectual property part. And to protect our system and prevent imitation, we developed a three-layer IP strategy. The first, with a utility patent, we protect the system's internal functionality, including the sensing power and AI processing. The second, with a design patent, we secured the physical structure and appearance of the hardware. And finally, we trademark the Vision Drive 360 brand so competitors cannot copy our name and marketing identity. Together, these measures provide both technical and commercial protection as we enter the market. To conclude our part, we need to say that Vision Drive 360 provides an affordable and scalable approach to upgrading existing vehicles with semi-autonomous capabilities. We address a major industry challenge. Fleets cannot afford fully autonomous vehicles, but they still need improved safety and efficiency. Our hardware and software system shows technical feasibility, and through our prototype and simulations, we demonstrated that the concept can work in real-world conditions. Overall, our solution creates real business value for fleet operators and improves safety and moves the industry closer to practical autonomy. Thank you for your attention, and our presentation is finished.